Today in this video I am going to explain how to find inverse of a square matrix by formula, which is also known as cofactor method. So let A is a square matrix 2 3 1 5 4 2 1 5 minus 1 be the matrix whose inverse is to be found. So I will explain it in steps. So step 1, find the determinant of A matrix. Since A inverse exists only if determinant A is not equal to 0, otherwise A inverse does not exist. So let's find the determinant of A, and here I am not going to explain how to find the determinant of a 3 by 3 matrix because I have created a dedicated video for the topic. So if you don't know how to find the determinant of a square matrix, you may watch that video. So here I am going to find the determinant of A with the help of first row. So I have written 2, the first element of the first row, and in brief I may tell or I may remind how to find the determinant of a square matrix. We write first element of first row, then the row and the column in which this element lies should be eliminated in mind, and the rest of the 4 elements are cross multiplied and a minus sign is put between them. So we have minus 4 minus 10, then in the next element is to be taken with negative sign and the row and the column should be eliminated. These 4 elements are left. Then we take cross multiplication, 5 into minus 1, minus 5, and then we put minus sign, and then we take cross multiplication of 1 and 2, that is 2. So minus 5 minus 2, then we put a plus sign and the next element of the first row, that is 1, and the column and the row are eliminated. These 4 elements are left. Then we take cross multiplication of these elements, 5 5s are 25. Then we put minus sign. Then we take cross multiplication of 1 and 4, that is 4. 1 4s are 4. So 25 minus 4 we get. Now let's simplify. 2 minus 4 minus 10 minus 14, so 2 into minus 14, minus 3 minus 5 minus 2 minus 7, so we have minus 3 into minus 7, plus 1 into 25 minus 4 is 21, so 1 into 21. So on simplifying, 2 into minus 14 minus 28 minus 3 minus 7, 21, plus 1 into 21, 21. As you see, there are 2 elements, 2 numbers which are positive should be added. So we get 21 21 42 and minus 28. 42 minus 28, simplifying we get 14, which is obviously not equal to 0. So A inverse exists. Now we come to the step 2. In step 2 we find cofactors of all the elements of matrix A. And here also I am not going to explain how to find the cofactors because I have created a dedicated video for cofactors and minors, and if you don't know how to find the cofactor of a square matrix, you may watch that video. So here I am going to write the cofactors of this matrix. So the cofactor of the first element of the first row, that is C11, which is equal to minus 4 minus 10, cofactor of next element C12, that is minus 5 minus 5 minus 2, and C13 is equal to 25 minus 4, and C21 is equal to minus bracket minus 3 minus 5 comma C22 is equal to bracket minus 2 minus 1, C23 is equal to minus bracket 10 minus 3, then C31, that is 6 minus 4, C32, which is equal to minus 4 minus 5 and C33 is equal to 8 minus 15. So as you observe, we have written plus sign between before the first bracket, and then we put negative sign before the second one, then positive, then negative, then positive, then negative, then positive, then negative, then positive. So in this way we put positive, negative, positive, negative alternately, as I have explained in the video of minors and cofactors. For the detail you may watch that video. So simplifying this, minus 4, minus 10, minus 14, C11 is equal to minus 14, minus 7, minus 5, minus 2, minus 7, and minus into minus plus. So we get 1 C12 is equal to 7. Next C13 is equal to 21, and C21 is equal to minus 3, minus 5, minus 8, minus into minus plus. So we get plus 8. And cofactor C22, we have minus 2 minus 1, that is minus 3. Cofactor C23 is equal to minus 10 minus 7, that is minus 7. Cofactor C31, that is 6 minus 4 is equal to 2. C32 is equal to minus bracket 4 minus 5, that is minus 1 into minus, so plus 1. And at last C33 is equal to 8 minus 15, which is equal to minus 7. Now we come to the step 3, write cofactor matrix. So cofactor matrix is the matrix of cofactors. So as we have found cofactors in the previous step, we write all these cofactors in the form of matrix, which is called cofactor matrix. So here minus 14, 7, 21, 8, minus 3, 7, 2, 1, minus 7. And now step 4, in which we find the adjoint of A, which is nothing but the transpose of a cofactor matrix. And transpose is the matrix obtained by interchanging columns and rows of a matrix. So transpose of this we obtain minus 14, 8, 2, because this is first column, so it becomes first row, minus 14, 8, 2. So first second column in the same way becomes second row, 7, minus 3, 1, and the third column becomes third row, 21, minus 7, minus 7. So in this way we find adjoint of a matrix. Now we come to the step 5. In this we use a standard formula for our inverse, so which is 1 upon determinant A into adjoint of A. As we have found these two in the previous steps, as determinant A is found to be 14 in the first step, and adjoint of A we have found in the step 4. So this is adjoint of A. So putting the values of determinant A as 14, we get 1 upon 14, and adjoint of A as this matrix. And by the scalar multiplication of a matrix, each and every element of the matrix is multiplied. So if we multiply 1 upon 14 and the matrix, it will multiply each and every element of the matrix. So 1 upon 14 into minus 1 upon 14, we get minus 14 upon 14, 8 upon 14, 2 upon 14, 7 upon 14, minus 3 upon 14, 1 upon 14, 21 upon 14, minus 7 upon 14, minus 7 upon 14. Now simplifying, 14 and 14 are cancelled, we get minus 1, and in the next element 8 and 14 both are divisible by 2. So dividing by 2 we get 4 upon 7, 2 4s are 8, 2 7s are 14. 2 and 14, 2 will divide 14 7 times, so 1 upon 7, and 7 will divide 14 2 times, 1 upon 2. Here minus 3 upon 14 as it is, because both have no common divisor, so minus 3 upon 14 as it is, and here 1 upon 14 as it is, and here 21 upon 14, both are divisible by 7. So 7 3s are 21 and 7 2s are 14. So ultimately we get 3 upon 2. In the next, both are divisible by 7. So 7 1s are 7, 7 2s are 14. We get minus 1 upon 2. In the same way, next element is minus 1 upon 2. So this is the way to find the inverse of a square matrix of order 3 by 3.